Okay, so here we are on question 9, 50-mark question, problem-solving question. Very quickly, you'll see that you're dealing here with a sequences and series question. A competitor is running a 20-kilometer race. So I'd be saying to students straight away, when you see this big block of text, that you're going to be highlighting the keywords to try and make it a bit easier to take in the information. She runs each of the first 4 kilometers at a steady pace of 6 minutes per kilometer. That actually makes this question a little bit unusual, because typically in a question like this, you're starting into a geometric series type of question straight away. But for the first 4 kilometers, it's a steady pace of 6 minutes per kilometer. After that, she begins to slow down. But a little bit of an irony here, of course, we know it makes sense that as she slows down, it takes more time. But as you slow down, in this case, you're going to be dealing with a number that's getting greater. So in order to estimate her finishing time, the time that it'll take her to complete each subsequent kilometer is modeled to be 5% greater than the time it took to complete the previous kilometer. So I'd say to a student, okay, read this question again. Some students will look at it and they might just balk at it and go on to another one. But again, I think once you get into it, it's not as bad as it seems. Show that her time to run the first 6 kilometers is estimated to be 36 minutes and 55 seconds. Okay, so what do? We start off. So we say, okay, the first 4 kilometers are ran at 6 minutes per kilometer. So 4 times 6 is 24. The 5th kilometer is 6 times 1.05. And the 7th kilometer, am I saying that right? No, the 6th kilometer then is 6 times 1.05 to be squared. That's 36.915 minutes. We got to sort out the 0.915 by multiplying it by 60 to get the seconds, and we round it to the nearest second and we get the correct answer. And it was a 10 marker. So look, it's possible that someone who had never done sequences and series could work out the answer to this question. But having said that, someone who has studied it might still find it difficult. By forming the equation for the 5th, 6th, and 7th kilometers, show that our estimated time in minutes to run the orth kilometer, so that's your general term, like it could be the nth kilometer, but just called r in this case, is 6 by 1.05 to the power of r minus 4. So here we go. The 5th kilometer, we saw that a moment ago, it was 6 times 1.05. The 6th one is 6 times 1.05 squared. The 7th is 6 times 1.05 to the power of 3. So if you look at these numbers here, like the power is always 4 numbers, four digits less than the actual term number. So for that same reason, the orth term would be 6 times 1.05 to the power of r minus 4. Now that was just a 5-mark question, okay? We're conscious of the fact that some people will probably get 0 for it because they just won't quite see how to start with it. But I'm hoping you'll remember this lesson here again that I mentioned before, that even if you got nothing for part B, even if you couldn't start it, you could still do part C. Using 6 by 1.05 to the power of r minus 4, find the time it takes in minutes and seconds to complete the 18th kilometer. Well, this is my general term for the time per kilometer. So the 18th one, all you got to do is put in 18. Simplify it down. We want minutes and seconds again. So we go through that same process of multiplying the 0.879 by 60. And I get my answer of 11 minutes and 53 seconds. So I hope that's okay. And you can see again that point that it wasn't that difficult. It wasn't that difficult to actually do part C, even if you were confused on part B. Now I'll take the unusual step here of doing part E before doing part D. So for part E, the final part, and we'll go back to part D then, it says calculate the estimate of the total time in minutes and seconds that she would take to complete the race. So in this particular case, we can see that for the first 4 kilometers, we know that she's traveling at 6 minutes per kilometer. And then she slows down thereafter for the next 16 kilometers, making 20 kilometers in total. The part in red there is a geometric series. It's a finite geometric series. So I'm going to use my SN formula. My first term A is going to be this guy, 6 times 1.05. This is my A. And my R is also going to be 1.05 because what's R? Well, it's term 2 divided by term 1. So R will be equal to 6 times 1.05 squared over 1.0, or 6 times 1.05. And of course, you'd just be left with the 1.05 in that case. So I get my A, which is my 6 times 1.05 times 1 minus my R, which is 1.05 to the power of 16, all over 1 minus R. And when I work that out, this is going to give me my total time to complete the race, 149. Well, actually, this is just, I got to be conscious of here, this is just my part in red. And 149.04. And I must add to that my 24 for those 4 kilometers where I was running at a constant pace. So it says this, it's 173.04. And when I turn that into minutes and seconds, it's 173 minutes and 3 seconds. And that was a 15 marker. Now, again, if you had kind of taken your time with the question, kind of spend time working it out, go through those first parts, and if you had the logic of the question, this part, hopefully you would have got the full marks in it. The part D, we did in this order. Of course, we could have put the graphing as the last part, but oftentimes it happens in the real exam that it's easier to do part E and then work your way back to part D than the other way around. Because in fact, if you have done this properly here, part D, you actually have the answer for part E, okay? But we had to show it kind of using the formula for the last part. Now this says draw a graph to show the total distance traveled throughout the race. Now you got to be careful that it is the total distance traveled throughout the race, okay? So it's your final distance. You know, it's not just like the distance per minute or anything like that. It is the total distance. So to give the finish, we know that after 20 kilometers, well, we know the time it took was the 173 minutes and 3 seconds. Okay, we know that from what we've just seen. We could, in the marking scheme, you will note that we have all of the points mentioned. So after 0 seconds, she traveled 0 kilometers. After 6 minutes, because that's our unit, after 6 minutes, she traveled 1 kilometer, and so on and so forth, right? And you know, we could work out this one by 6 times 4. That was our 24 minutes to do the first 4 kilometers, plus 6 times 1.05. Now, you could do it for them all, right? You could find every single one, or else you could just maybe pick a few and draw the curve like that. But again, you would probably need to use the SN formula for it. Or what you could do, you know, if you knew how long it took to get the 5th kilometer, you know, to have done, oh yes, I see what it is here. I see. I knew there was something wasn't quite right. These two are in the wrong way around. To have traveled 5 kilometers takes 30.3 minutes. Okay. So then if you knew that, then you figure out how long it takes you to get the 6th kilometer and add it on, etc. And you can keep going like that all the way to the end if you wish. Okay. Or you could just pick a few of the points like we have here and draw the graph from that. And that was a 10 marker. So, you know, that part was was, I suppose, made a little bit obscure on purpose to make you think and to just have something a little bit different in there, so the question wouldn't be too straightforward and too easy for you. And I hope overall you found, those of you who did it found that it was okay, and those of you who chose not to do it in the exam and are looking at it now have maybe learned something from it. Okay, let's move on to the final question, question 10.